Hello everyone, my name is Vaidehi Chaudhary. I am from MIT Academy of Engineering, Alandi, Pune. So there is a school of civil engineering and we are preparing the presentation on the topic of in-situ geotechnical investigation by the cone penetration test. And this presentation was prepared by myself and guided by the V.V. Muttekar sir from the MIT Academy of Engineering, Alandi, Pune. As we know, we are the civil engineers and we have to perform some different types of test in situ for the soil. And the penetrometer is a test which is a one of them. This is a done to determine the different mechanical properties of the soil. There are namely three types of penetrometers are there, which is a standard penetration test, static cone penetration test, dynamic cone penetration test. These are the types or these are the tests we are performing to find or determine the mechanical properties of the soil. All three types of the soil are measures the resistance of the soil strata to penetration by the penetrometer. The SPT is carried out in the hole while the SCPT and the DCPT are carried out without the hole. So today we will talking about the static cone penetration test. The static cone penetration test, it is a type of a cone penetration test. It is also known as a Dutch cone test and it's having its own IS code, that is IS 4968 part 3 year 1976. The method of a surface surrounding for the soil part 3, the static cone penetration test. So in this presentation, we will see about what is a static cone penetration test. The static cone penetration test, it is a type of a cone penetration test in which the cone is used to penetrate the ground surface. As we know in the SPT, we are creating the hole, but in this static cone penetration test, we does not creating any hole. We just insert our cone inside the ground surface to determine the properties of the soil. In SCPT, we do not apply any hammer or blow as seen in the DCPT. We push the hammer into the soil at a particular rate of 1 centimeter per second. In the case of SCPT, we will be measuring the continuous data. So we will get a continuous measurement of the resistance to penetrate of the cone and the surface leaves. The static cone penetrometer consists of a steel cone, a friction jacket, sounding rod, mental tube, a driven mechanism and the measuring equipments. And for that purpose, we have some requirement of the equipments which are the porous filter elements for measuring the pore and water pressure. This is a cone of a 3.6 diameter having the angle is a 60 degree. The cone has an apex angle 60 degree plus minus 15 and an overall base diameter of a 35.7 mm and gives the cross sectional area is about a 10 mm square. The friction leaves has an area of 150 centimeter square as per the standard practice. The sounding rod is a steel rod. It has a diameter of a 15 mm which can be extended with an additional rod of 1 meter length each. So we can conduct the test for up to the requirement length. For the manual operation, the driving mechanism must have the capacity of 20 to 30 kilonewton, and for the mechanical proportions, the driving mechanism must have the capacity of 100 kilonewton. In this test, we does not require a borehole, but it takes a sample with the help of a split spoon cone. As we know, we does not creating any hole in this test, so with just a requirement of the sample we can collect it from the with the help of a split spoon cone. After that we will see about why the static cone penetration test is needed to determine the characteristics of the soil for the softening of the soil, silty, sandy, clayey and some coarse cohesionless soil such as the soil type, relative soil density, in situ stresses condition, shear strength parameters. For that purpose, we are performing the static cone penetration test. After performing the test, the data obtained can be used to determine the soil type, design the shallow foundation in the cohesive soil. It is can be used directly for the designing for the pile foundation in the sand, gravel and indirectly for the shear strength for the pile in the clay. For that purpose in we are using the standard code penetration test. After that, we will see the what is the principle of a static cone penetration test. A static cone penetration test involves the penetration of a cone inside the ground and measures the cone resistance, frictional resistance, friction ratio, and pore water pressure. For calculating the pore water pressure, friction, and the resistance created by the soil surface, we are measuring with the help of a static cone penetration test. And for that purpose, we are requiring some apparatus, which are the steel cone, a friction jacket, sounding rod, mental tube, a driven mechanism, and for the measuring equipments. After that, we will sing about how to perform the SCPT with the help of a procedure. First step, the cone and the friction jacket assembly is put vertically touching the ground. After that, the cone is then pushed down at a constant speed of penetration ranging from 1.5 to 2.5 cm per second to the depth, say for this 40 mm. Then the cone tip resistant QC is recorded. For the depth of a 40 mm, we are pushing our rod at a constant speed, that is a 1.5 to 2.5 centimeter, with the help of pushing. Then we can calculate, or we say we can record it the QC. After that, now the sounding rod is pushed further to the depth of a B, say 40 centimeter. Then the sleeves friction QF is recorded. After that, then the mantle tube is pushed down to the A plus B depth, that brings the cone and the jacket assembly to the step 1. After that, then the friction ratio is calculated using the formula RS is equal to QV upon QC. After that, we will sing about the advantages of the SCPT. There are some advantages, which are the SCPT is a very simple and the rapid test. As we know in civil engineering, there are so many tests which are very difficult to perform and time consuming. But this test is very simple and a rapid test. After that, this test is economical to perform as they do not having any cost equipments. Then the test is a help to identify the problems of the soil. The test is provided us with the detailed and the precise data. This test help us with the real-time measurements. These are some advantages. After that, we will sing about the disadvantages of the SCPT. The soil sample is not obtaining in this test. The depth till which we can carry out the test is limited. The cone cannot be pretended through the gravel surface. This test requires the special equipments and the skilled laborers. After that, there are some precautions to be taken while performing the test. The test should be conducted carefully and the data should be recorded precisely and continuously. There should not be any time gap or the time limitations or the time overlapping. A large number of tests should be carried out for the more accuracy. The test data can be influenced by the various factors such as the pore pressure, humidity, the temperature, so they should be managed as per the standards. After that, we will sing about the dynamic core penetration test, which is the second part of the cone penetration test. We will see about why we need to dynamic cone penetration test as we having the SCPT to determine the shear strength, bearing capacity, location, and the thickness of a sublayer of the soil. As we will cannot be considered, or as we cannot be determined this type of parameters in the SCPT. So for that purpose, we are having the dynamic core penetration test to monitor the conditions of the granular layers and the subgrade soil in the pavement section over the time to determine the right solution for the site of the customer, especially when the soil is soft, are involved. After that, which equipments are required to carry out the dynamic cone penetration test? The requirement of the equipments are the standard diameter steel rod and the hardened conical tip and the hammer. These are the simple equipments we are requiring for the dynamic cone penetration test. After that, what is the difference between the static cone penetration test and a dynamic cone penetration test? So we will see what is the static cone penetration test. It is a useful for the very soft and a loose soil, but in a dynamic cone test, it is useful for the hard soil such as a dense gravel soil or the cohesionless soil. And in a static cone penetration test, it is a test the cone is pushed in the gravel by the thrust or not by the drilling. But in a dynamic penetration test, This test was done with the help of a driven into the ground. After the SCPT, in this test, the cone is used to called as a split spoon sampler, take the soil sample inside it. But in this dynamic cone test, the cone is used to closed end and does not require any sample. In the SCPT, the test is gives the continuous measurement, and the dynamic cone penetration test, this takes the blow counts at a ratio of 1.5 meter depth interval. After the 1.5 depth meter interval, we are calculating or we are recording our counts of blows. Then in a SCPT, this is a test is done to determine the soil consistency, bearing capacity and the level of a pavement and the foundation. But in a dynamic cone penetration test, this test is done to determine the shear strength inside the soil, location and the thickness of the sublayer soil. So this is the difference between the dynamic cone penetration test and the static cone penetration test. After that, what is the principle of a DCPT? The basic principle of this test to measure the resistance offered by the soil layer to cone is used to conducting the test. And which are apparatus is required: the cone of the 50 mm without detonite slurry, the driving rod, driving head, hystenesting equipment, a hammer made up of a mild steel or a cast iron with a base plate of a mild steel weighing the 460 Newton, that is a 65 kg. After that, what is the procedure to perform this DCPT? The initial reading on the dynamic cone penetration test is recorded. After that, the dynamic cone penetration test is kept with the cone resting on the vertical of the ground where the test is to be carried out. Now, the cone is driven inside the soil by the free fall of the hammer of a height is a 750 mm each time. After the every blows, the height will be remain constant. Then the number of blows of every 10 mm penetration is recorded. After the one time penetration, the every 10 mm depth, for the every 10 mm depth we are penetration can be recorded. This process is repeated until the cone does not reach the required depth. After that, some advantages of the DCPT is the test is does not need any borehole. Then the test is can be performed it quickly so that it covers the large area, making the economical. And disadvantages are this test cannot be performed on a cohesive soil or a very loose cohesionless soil. It is not possible to determine the mechanical properties of the soil by this test if the soil is at a great depth and the friction along the existence of the rod is significant. After that, the factor affecting the DCPT, we can see there are some various factors which affects the test, such as the alignment of the DCPT rod, damages cone tip, the depth of a testing, the apex angle of the cone, hammer weight, free fall height of the hammer can be constant at every time, the moisture content, material composition, intensity of the compaction. These are some factors which are affecting on the DCPT test at the time of performing. And for that purpose we can and take the precautions. The precautions can be taken as the reading should be taken number of times to reduce the error. We can take the number of readings to reduce the error while performing the test. For that, the during the free fall of the hammer, it should be raised to standard height, otherwise the penetration value will be decreases. For that, the DCPT test should not be done during the monsoon because it is a decrease that the strength of the soil and the test result will be accurate. After that, the conclusion is to be there. This test helps to save the money for the owner by identify the geological strata more accurately. This test also helps in the seismic evolution to satisfy the new building code requirement with the measurement of the low strain shear strength wave velocity. Then this test can be further is to be predict the pile capacity and also provided a good estimate of the settlement for the shallow foundation. This is the conclusion.